Hi everyone. So today we're starting our first lesson in math, which is lesson 1.1, model place value and relationships. So our essential question, what we're learning today, is how can you describe the value of a digit? And so hopefully you know a digit is simply just a number, a single number. So 0 through 9, those are all of our digits that we use to create numbers. And the most important thing that we're going to be talking about today is called place value. So possibly since, first, second, third grade, you've been learning that there are different places that numbers fit in, and we call it a place value. So we're going to be taking a look at a place value chart. And this kind of is like one, but just so that you can kind of see, we need to know that numbers can fit into different places. So we have the ones place, the tens place, the hundreds place, and we're going to go all the way up to the millions place in fourth grade. So these should be kind of familiar, the thousands place, and then we're going all the way up to 10,000s, 100,000s, and millions. So pretty big numbers that we work with in fourth grade, which is pretty cool. So how can we describe the value of a digit? Well, think about how numbers work. The number 5 is a lot different, like having 5 erasers is a lot different than having 500 erasers, right? So how do we know that, which one is less, which one is more? And we always use place value. So how can we find the value of digits? That's what we're going to learn today. And one of those is going to be using a place value chart. But another way that we can determine place value is with models. So these might look familiar. We have the cube, which is one, its value is one single cube. We also have the long, or I call it the rod too, because it kind of looks like a rod. And it makes up 10 cubes. So you could call this 110. We also have the flat, which has 100 of these little cubes. So that's a total of 100. So we call that a flat. And then we have the 1,000 cube, which has 1,000 of these little tiny cubes. And we just call that the big cube. So before we move on, I just wanted to show you guys a fun kind of little thing that's a little interactive. And so it says we can start by choosing some blocks. So again, the little cube represents 1. The rod represents, or the, what did they call it? I already forgot what it was called. The long, see, I always call it a rod. The long represents 10. And we have the flat that represents 100. This one doesn't have the thousands cube, but that's okay. So what do you notice as we look at the increments going? So we have the one little cube, we have 10, we have 100. Is there anything that you notice? If you think about it, I'm going to use this little pen. If you think about it, this has 1, right? And this has 10. So, and then this has 100. So if you're noticing something, they're all numbers that are base 10. And that's why we call these base 10 blocks, because the one previous to the other is 10 times the amount of the one before it, which is pretty cool. So 1 times 10 equals 10. 10 times 10 equals, what do you think? 100, right? And so on and so on. So if I did 100 times 10, that would get me that big, huge 1,000 cube, right? Because 100 times 10 equals 1,000. And there's my squiggly 1,000. So these are base 10 blocks because they are multiples of 10. Each place value, if you think about it, it's 10 times the amount of the previous number. So that's kind of a way to think about how these blocks work. So it takes 10 of these to make one of these, and it takes 10 of these to make one of these. If you count all these, we're going to find that there's 10 longs or rods. So when you think about that big, huge 1,000 cubes, it takes 10 of these flats to make one of those big, huge cubes. So it's all base 10. So just to give you an idea how to think about that. All right, so back to here. So there's a pattern here. We have the cube, long, flat, cube. What do you think 10,000 would look like if we had 10,000 of these little tiny cubes? If it followed this pattern, what do you think would come next? Cube, long, flat, cube. If you're thinking long, you're right. And that model would be so big, it would be hard to even fit on the screen. So they kind of just left it up for us to imagine what it would look like, but it would look more like a long. So like I was just showing you guys in that interactive place value models, you'll notice that it goes by base 10. So it's 10 times the amount of the previous model. So 1 times 10 equals 10. 10 times 10, so it takes 10 of these to make one of these. So 10 ones to make one long. It would take 10 tens or longs to make one flat. It would take 10 flats to make one of these big cubes, so it takes 10 hundreds, because remember this represents 100. And it would take 10 of these to make a 10,000 flat, which is probably a lot of little cubes. So, oops, I almost gave you guys answers. So thinking about the patterns of how base 10 works. So thinking about how many of these make one of these, hopefully you said 10. Okay, so it takes 10 of these to make one of these, 10 of these to make one of these, 10 of these to make one of these. That's how base 10 works. So it's multiples of 10. All right, so a small cube represents 1. So how many small cubes make a long? And we were just saying how many little of these little tiny cubes are in this one long? Hopefully you know 10, right? And the long represents 1, 10, because there's 10 little cubes in there. How many longs make a flat? We were just saying, hopefully you remember, it takes 10 longs or tens to make a flat. And the flat represents a total of how many cubes? Hopefully you're thinking 100, right? There's 100 little cubes here. How many flats make a large cube? And again, it's all that base 10, 10 times whatever this was. So yep, 10 flats makes one large cube. The large cube represents 1,000. So that's that. So that's how we can use models. Let's think about now how we can use a place value chart to help us find the value of a digit. So what is a digit? It's a number, a single number, and we can find the value of a digit by using a place value chart. So if I just stick a 4, in the hundreds place, is it still a 4 anymore? Or maybe did that change its value? And then what numbers would I have to put after that 4 to make sure I'm representing that it's 400? So that's kind of the way that you have to think about these numbers. So before we do this activity, I want to show you another cool place value chart. And I'll give you guys these links too so you can use these tools. And so again, this is a place value chart. It has its ones, tens, hundreds, thousands, 10,000s, 100,000s, and millions. And what I can do is I can drag these numbers down and it tells me the value of that digit. So the 9 is in the ones place, so the value is just 9. But what about if I put a 9 in the hundreds place? Do you see what happened? What happened? It added zeros at the end. Why? Because if you put a number in the hundreds place, it's no longer value is just 9. Now its value is 900. And we have to hold the place of the tens and ones with zeros to make sure that this says 900. So let me clear that out. So let's see if I put a 6 in the 10,000s place. Is the value going to be only 6? I don't think so, right? So the 6 is in the 10,000s place, so its value is 60,000. So all the places that come after it have to hold zeros to give you the value of just that single digit. All right, so let's do a bigger number. What if I had something like this? Okay, and I just want to know the value of the 5. Is the value of the 5 only 5? No, because what place is it in? It's in the hundreds, right? So the value of that 5 isn't 5, it's not 50, it's 500 because the 5 is in the hundreds place. And you can see down here it's giving us expanded form. We'll talk about that in the next lesson. But it shows you the value of the 5 alone is 500. So if I want to know the value of just that digit, I would just put that single number and then any places after it that I need to hold with zeros. The value of the 4 is 4,000. The value of the 3 is 30,000. So it depends where the number is in a place value chart to determine how much its value is. All right, so let's go back to this slide. So this question asks us to write 894,000. So when I see that comma, that means I need to read the place that it kind of left off on. So it'd be 894,613. We're going to write that in this chart, and then we just want to find the value of the digit 9. So in our place value chart, we have the millions, thousands, and ones. And these are called periods, the millions period, the thousands period, the ones period. And that's where you see each period has ones, tens, and hundreds in it. So if I am going to write 894,000, it's kind of like, okay, then where do I start? So thinking about there are 1, 2, 3, 4, 5, 6 digits in this number, that means I need to use 6 of these boxes. Do I have any millions in this number? No. It only goes up to 100,000s. So we actually don't even need to use the millions box. We're only going to use the thousands and the ones. So we're going to do 8, 9, 4, 6, 1, 3. And you're going to plug in those numbers into the place value chart. And then we can see the values of the numbers. Let me show you how it looks plugged in. So we have 894,613. The reason I didn't start up here is because these digits value are not in the millions. So if I had written 894,613, it wouldn't be right because then I wouldn't have any numbers in the ones. So we don't need to even use this part of the place value chart. If we had millions, then yes, we would have. And then it gives us all the values here. So the value of the 8 is 800,000. But we want to know find the value of digit 9. So I want to look right here in this blue writing. It says that the 9 is in the 10,000s place. So what would be the value of that 9? 9 10,000s or 90,000. So the value of the digit 9 is in the 10,000s place, or its value is 90,000. So you keep the 9 and everything after it becomes a 0 just to give the value of that one single digit. All right, so I want you to try. So what you can do right now is you can pause the video and solve these. If you have a paper pencil handy, you might even want to copy down this place value chart so that you have one kind of like right in front of you. I'll also post a place value chart with this lesson to, if you have a printer at home, you could print it, or if you could just use it as a visual, but it might help to draw one. And then I want you to solve these problems, finding the value of the digit 4 in the number 1,264, find the value of the digit 6 in the number 652, and find the value of the digit 5 in the number 5,009. So pause the video, solve it, find the value of the digits that are underlined. All right, so hopefully you paused the video and solved these 3 problems, and let's check your work. So the first one, the value of the digit 4 in this number is only 4 because the 4 is in the ones place. You didn't have to write any zeros after it because there's no numbers after the 4. The value of the digit 6 in this number is 600 because the 6 is in the hundreds place. And the numbers after become zeros because we only want the value of the 6. To find the value of the digit 5, you should have kept the 5 and made everything after a 0, and it is in the thousands place. So 5,000 is the value of this 5. So hopefully that made sense, finding the value of a single digit within a number and making sure you're using those kind of, I call them placeholder zeros that come after. All right, so the last part of this lesson is going to be comparing numbers. And again, thinking that these numbers are base 10. So depending on where the number is, it could be 10 times as big as the other number. So you'll notice that in both of these numbers, the 3 is underlined. They want us to compare the value of this 3 with this 3. But what do you notice? Are they in the same place? No, right? In 2,304, the 3 is in the, hopefully you notice, the hundreds place. And this 3 is in the, hopefully you see it's in the tens place. So if it's in a different place, that means they have a different value, right? So if we want to find the value of the 3 in this number, we could plug that number into a place value chart. You could put the 2 in the thousands place, the 3 goes in the hundreds, the 0 goes in the tens, and the 4 goes in the ones. We wouldn't start way up here because, again, is this the hundred thousands place? No. So we are going to start by writing the number 2 in the thousands place. And you can even go backwards if that helps you. You could put 4, 0, 3, 2. That might help a little bit. And then it's going to give us the value of the digit 3 in that number. And where did the 3 end up? It ended up in the hundreds place. So that means that the value of the 3 is 300. And the model shows over here too, 3 flats equals 300. So we found out so far the value of this 3 is 300. Let's find the value of the other 3. So this 3 is in the tens place, right? So if you put it in a place value chart, we have 16,135. And the value of the 3, if the 3 is in the tens place, what do you think would be the value of the 3? It's not just 3, right? And it's not 300 because it's on the hundreds. The value is, and you can even count these are tens, 10, 20, hopefully you said 30. So the value of the digit 3 is 30 in this number. So the other one was 300. This one's value is 30. And if each 100 is 10 times as many as 10, so it's 300s is 10 times as many as 3 tens, the value of 3 in 2,304 is 10 times the value of 3 in 16,135. Because remember what I said, you can like think of it as times 10. So 300 is 10 times the amount of 30 because 30 times 10 is 300. So all you had to think about again was that 10 times the amount. 300 is 10 times bigger than 30. And if you were just doing like a comparison, which we'll do in lesson 3, we would have said that this number is bigger than this number, but that'll be in another lesson. All right, so let's try that one. You're going to compare the values of the underlying digits in these two numbers. So I have 5 as our digit we're comparing, but this 5 is in this place. I'm not going to tell you what because you're going to figure out. And this 5 is in this place. So they're in different spots. So I want you to think first, what's the value of this 5? What's the value of this 5? You can pause the video to figure that out. Find the value of this 5 and find the value of this 5. All right, so hopefully you paused the video and you found that the value of this 5 is 5,000. The value of this 5 is 500. So that means 5,000 is 10 times bigger or more than 500. So the value of 5 and this number is 10 times the value of, oops, that was supposed to be a 5 in this number. So again, it's just 10 times as many, 10 times bigger. All right, so you're going to try this now by going on Think Central, and I will upload these slides. You could either click here to get to Think Central, or you could go to the link in the login information, and you're going to complete the assignment for 1.1, which was today's lesson. I'd also like you to complete the attached exit slip in Google Classroom for this lesson. And if you want some extra practice, you could also go into your workbook that you have at home that I sent home, and you could do share and show on your own and problem solving on page 7 and 8. So that's it for today. We learned how to find the value of a digit by using models and using a place value chart. And I will attach a place value chart if you would like to have one printed out, or you can copy it and draw it. All right, so I hope that everything made sense. If you have questions, you can comment on this lesson or bring any questions you have if you're a remote student to the after school tutoring session with a teacher, and maybe they can answer some questions as well.